Hey everyone, and welcome. Today we're tackling a neat little problem from Leetcode. Find lucky integer in an array. It sounds fun, and it's a great exercise in counting things efficiently. Let's break it down together. Okay, so what exactly is a lucky integer? The problem defines it for us. We're given a list of numbers, which the problem calls R. A number is considered lucky if its frequency, that is, the number of times it appears in the list, is exactly equal to its own value. For example, the number 5 is lucky if it appears exactly 5 times. Our job is to find all the lucky numbers in the list and return the largest one. If we can't find any, we simply return -1. Let's walk through an example to make sure we've got it. Imagine our input array is 1, 2, 2, 3, 3, 3. First, let's figure out the counts for each unique number. The number 1 appears just once. Is its count, 1, equal to its value, 1? Yes, it is, so 1 is a lucky number. Next, the number 2, it appears twice. Is its count of 2 equal to its value of 2? Yep, 2 is also lucky. Finally, the number 3, it shows up 3 times. And again, the count matches the value. So we have 3 lucky numbers here, 1, 2, and 3. The problem asks for the largest one, so we'd return 3. So how do we translate this logic into a program? The most straightforward way is to use a data structure designed for counting, a hash map, which is called a dictionary in Python. The idea is simple. First, we'll make a single pass through the input array to count up how many times each number appears, storing these counts in our map. After that, we'll iterate through our map, looking at each number and its stored count. For each pair, we'll ask, is the number equal to its count? If it is, we know it's a lucky number, and we'll compare it to the largest lucky number we've seen so far. Here's what that looks like in Python. We can use the counter object from the collections library, which is a specialized dictionary that does all the counting for us in one simple step. We initialize our best answer so far, which we're calling lucky_number, to -1. Then, we loop through the items in our counter. For each number and its frequency, if the number equals the frequency, it's lucky. So we update our lucky_number variable to be the maximum of whatever it was before, and this new lucky number we just found. After checking all the numbers, we just return the result. Now for a slightly different approach, which takes advantage of the problem's constraints. The problem statement tells us that the numbers in the array will always be between 1 and 500. When you have a small, fixed range of positive numbers like this, you can often use a simple array as a frequency map, which can be a little more efficient. We can create an array of size 501 and use the index of the array to represent the number and the value at that index to store its count. Then, we can just loop backwards from 500 to find the biggest lucky number first. And here's the code for that idea. We start by creating a frequency array called frec, filled with zeros. We then loop through our input array. For each number we see, we go to that number's index in our frequency array and increment the count. Now for the clever part. Since we want the largest lucky number, we can loop backwards, from 500 down to 1. The very first time we find an index, let's call it I, where the count stored at that index is also equal to I, we've found our answer, we can return it right away. If the loop finishes without finding anything, it means there were no lucky numbers, so we return -1. So how do these two solutions compare in performance? For time complexity, both approaches need to look at every number in the input array at least once. So we can say they both run in big O of n time, where n is the number of elements in the array. For space, the hashmap approach uses space proportional to the number of unique numbers in the array. The array approach, on the other hand, uses a fixed or constant amount of space determined by the problem's constraints. In this case, an array of size 501. Both are very efficient for this problem. Alright, let's recap. We saw that this problem is all about frequency counting. We explored 2 great ways to do it. The first, using a hash map, is a very common and flexible pattern that you'll use all the time. The second, using an array as a frequency map, is a clever optimization that's perfect for when you know the range of numbers is small. The big takeaway here is to always pay attention to the constraints of a problem. They can often give you a hint about the most elegant and efficient solution. I hope this breakdown was helpful. If you learned something, please hit that like button and consider subscribing for more Leetcode explanations. If you have any questions or a different way to solve it, drop a comment below. And hey, if you're feeling extra generous, there's always the Boba Fund. Thanks for watching, keep up the great work, and I'll see you in the next one.